Hello learners, I am Rajati, Assistant Professor in Computer Science there at the Nabakyam College. Today we are going to discuss about number systems and codes. In the number system, we have decimal numbers, binary numbers, octal numbers and hexadecimal numbers. So decimal, we have a base 10. In binary, we have a base 2 and octal base is 8 and hexadecimal base is 16. So here decimal number is from 0 to 9 and binary is 0 and 1 and octal we have 0 to 7 and hexadecimal numbers 0 to 9 and here not is 10 11, instead of 10 11 we have A to F. So these are the topics covered here. Now number systems and codes have binary number system and decimal to binary conversion and binary to decimal conversion. Okay, first binary number system. So in this topic, we have three topics: decimal odometer and reset and carry, binary odometer. So let's see one by one. So binary number system. So the binary number system is a system that uses only digits 0 and 1 as code, and all other digits 2 to 9 are thrown away. So we already know computer only understand the binary codes, which is nothing but 0 and 1. So other than 2 to 9 will be neglect. So to represent decimal numbers and letters of the alphabet with the binary code, you have to use different string of binary digits of each number and letter. First, we discuss about what is decimal odometer. To understand how to count the binary numbers, it helps to review how to odometer mile. So for example, odometer miles indicated in a car counts with decimal number. When car is new, the odometer start 000. We already know. So after 1 kilometer, the reading becomes 0001. So successive kilometer produce 2, 3, so up to 9. So this will be the working process of the decimal odometer. Okay, next reset and carry. So the units will have reset to 0 and send the carry to 10 speed. So for instance, after 999 kilometers, the odometer shows 009. So this is the tens. So what does the next kilometer do? The unit will reset and carry the tens wheels. Reset the carries. For example, this is the tens. So it will be reset as a hundreds wheel and reset and carry and the thousands wheel after by advanced by the 1 to get 0 1 000. So this is the 100 position, so this is the 10th position. Next, binary odometer. So we already know what is binary. It's a 0 and 1, right? So visualize the binary odometer as a device whose wheel have only 2 digits. We already know that 0 and 1. So when each wheel turns, it display 0, then 1 and then back to 0. So it will be loop cycle repeat. A 4-digit binary odometer starts with 0000 and after 1 mile it will indicate 000 and 1. So next mile it will be 00 and then 10 and after that 0011. So after it will be increased in this way 0100 because it's a binary odometer. In a decimal odometer we saw 0001 0002 like this way in a decimal odometer, but in a binary odometer we only have a 2-digit 0 and 1. So this is the 4-digit binary numbers. So here this is the binary values. So this is the equivalent decimal number. For example, 0 is equivalent decimal is 0. So 0001 is equivalent decimal 1. 0010 means 2. 0011 is 3 and 0100 is 4. So like this way binary value and corresponding decimal value is present in the table. Okay, next topic is binary to decimal. So in this topic, we covered the topic positions, notations and weights, binary weights, streamline method, mixed numbers and fractions. First, binary to decimal conversion. So this section shows how to convert a binary number quickly and easily into its decimal equivalent. So positional notations and weights. For example, we have to know what is position and what is notation and what is weight. So this is the example. So 435.18. So this is the number. So we can call this as an integer, and this is the position 2, 1, 0. So after the point we have a position -1 and -2. So the weight will be 10 power 2, 10 power 1, 10 power 0, and after that point it will be calculated as 10 power -1, 10 power -2. So 10 power 2 means the answer will be the 100, 10 power 1 will be 10. So anything power 0 will be 1, and 10 power -1 will be can be written as a 1 by 10. So 10 power -2 means we can write as a 1 by 100. So this is the way the ways calculated. Okay, so position, notations and weights. So we can express any decimal integer. Integer means we know it's a whole number in units, tens, hundreds, thousands and so on. For instance, decimal number 2945 may be written as 2000 plus 900 plus 440 plus 5. In power of tens, this will be becomes, for example, so this value to 2945, it will be written in the power of terms means this will be the equation 2 into 10 power 3 plus 9 into 10 power 2 plus 4 into 10 power 1 and 5 into 10 power 1. So 10 power 1 will be the 1. So 5 into 1 will be the 5. So same like 10 power 1 will be a 10, and then 4 into 10 we have 40. So same way 10 power 2 is 100. So 9 into 100 will be 900. So here 10 power 3 will be 1000. So 2 into 1000 will be 2000. So the same way we can write this also. So both are the same meaning. Next, binary to decimal conversion. The decimal number system is an example of position notation. Each digit position has a weight or value. So we can call this as a weight or value. With decimal numbers, the weights are units, tens, hundreds, thousands and so on. The sum of all digits multiplied by their weights give the total amount be represented. For example, 2 is multiplied by its weight of 1000. So we before that we saw the example, right? So 9 by the weight of 100, 4 the weight of 10 and the 5 weight of 1. So totally 2945 will be written in this format, 2000 plus 900 plus 40 plus 5. Next, binary weights. The similar way we can rewrite any binary number in terms of weights. For instance, the binary number 111 becomes 111. We can write this as 100 plus 10 plus 1. So in decimal number, this may be rewritten as 4 plus 2 plus 1. Because it's a decimal, so we can use these numbers. But in a binary, we have to only use zeros and ones. So we can write this foregoing equations will be 1 into 2 power 2, 2 power 1 and 2 power 0. So this is the bit position and the equivalent weight is given in the table. So next, streamline method. So we can streamline binary to decimal conversion by the following procedure. The first, write the binary number, and then binary system weights will be 1, 2, 4, 8, 16, 32, 64 and 128. So this will be called as 2 power 0, 2 power 2, 2 power 3. Okay, so this is the 2 power 1 will be 2 power 0 and 2 power 1, 2 power 2 will be 4, 2 power 3 will be 8, 2 power 4 will be 16, 2 power 5 will be 32. So like this way it's go on. And directly under the binary number, write 1, 2, 4, 8, 16. So working from right to left. So in this way, right to left. If 0 appears in a digital position, cross out the decimal weight for that position, add remaining weights to obtain the decimal equivalent. So these are the methods followed in the streamline method. So this is the streamline method example. So in the power 2 power 0, so first write in the first one, write in this way. So starting from the right side, 1 into 2 power 0. 2 power 0 is 1. Anything power 0 will be getting 1. And 2 power 1, so which the number have 0, which is multiplied by anything, it will be 0. So this is the way we can calculate from binary to decimal conversion. So in this way we can calculate the method from conversion binary to decimal. This table indicates binary to decimal. The same number will be and then corresponding binary value present in the table. Okay. Next, we just know about the fraction. So far, we have discussed binary integer, which is nothing but a whole number. So, we have to know how our binary equation, binary fraction converted into corresponding decimal equivalent. For instance, what is the decimal equivalent of 0.101 and 000? Here, so still now we just see the whole number. So whenever it move on to the fraction, the power will be 2 power 0, 2 power 1. So here after the point, this is the point. Okay. So after that point, the power will be 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4, 2 power minus 5 and 2 power minus 6, 2 power minus. So it's go on. So 2 power minus 1 will be written as 1 by 2. 2 power minus 2 will be written as 1 by 4. 2 power minus 3 will be written as 1 by 8. 2 power minus 4 will be written as 1 by 16. 2 power minus 15 minus 5 is written as 1 by 32. 2 power minus 6 will be written as 1 by 64. In this way, we can calculate a even fraction number to the decimal. Next is mixed number. So mixed number is nothing but numbers with an integer and a fraction part. Handle each part according to the rules just developed. So we already see. So this is the integer part, and after the point we have the fraction part. So one is the fraction part. So we know fraction part indicated the 2 power minus 2 power minus 1, 2 power minus 2 in this way. So before that the left side we can indicate 2 power 0, 2 power 1, 2 power 2, 2 power 3. So this is the table. We have power of 2 and the corresponding decimal equivalent and then some abbreviations. So some examples of mixed numbers. So 111.0.001. So after that point the power will be 2 power minus 1. Before that point we can use here 2 power 0, 2 power 1, 2 power 2. But here 2 power minus 1, 2 power minus 2, 2 power minus 3. So according way we can calculate the mixed number also. Okay, next decimal to binary conversion. So here we cover the topic double table and fractions, useful equivalent, BCD 8421 code and BCD 2421 code. So let's see one by one. Decimal to binary conversion. One way to convert decimal numbers into its binary equivalent is reverse the process described in the preceding sections. So it's like a reverse order because we already study how to convert binary to decimal, right? So it's a 2 power 0, 2 power 1. But here it's a reverse order. We are using the double table method, a popular way to convert decimal numbers to binary in the double table method. So this is called a double table method. So we after that, so here 10001, it will be the a reminder, and we can write in this way. So from top to bottom we can write the answer of binary value. Binary to decimal conversion. In double table method, you can progressively divide the decimal number by 2. So this is the 2. We have to divide by 2 and write down the remainder after each section. So 250 into 2 we will be 100. So there is no reminder. So if no reminder means we can write just 0. And the reminders taken in the reverse order from the binary number. So if you have a reminder means write here. If you have a 0 means write 0. So after all the equations, all the remainder will be 10 10 10. This format, just stop and then write answer from bottom to top in this method. The same way. So in a binary to decimal conversion, we already see the fraction part the same way. Here also we have the fraction part. As far as fraction are concerned, you multiplied by 2 and, record a carry in a integer position. The carries read downwards or the binary fraction. Next, useful equivalence. Whenever a binary number has all ones, consist of only ones, you can find its decimal equivalent with this formula. So which is nothing but decimal 2 power n minus 1. So n is the number of bits. For instance, 1111 has 4 bits. Therefore, its decimal equivalent to the 2 power 4 minus 1. So 2 power 4 will be 16 and minus 1 equal to 15. So this is the way we can calculate. So this is the table of binary to decimal equivalence. So the corresponding value of decimal and the binary value is given. So next BCD 8421 and BCD 2421 codes. So BCD is a binary coded decimal, refers to representation of digits 0 to 9 in a decimal system by 4-bit unsigned binary numbers. The usual method is to follow 8421 encoding, which employs conventional route of weight placement like 8 representation. The weight of the fourth place 2 power 4. It's a 2 power 4 minus 1 is 8, and that is third place, second place, first place. So 2421's code is similar to 8421 code, except the fact that weight assigned the fourth place 2. It's not 8. So this is fourth place is a 2, so not a 8. So here the same decimal number. So what is the BCD 8421 code and what is the code of 2421 code? So only the changes started from 5 only. So 5, the BCD 8421 code will be 0101, and then BCD 2421 is 1011. So the changes will be started from the 5. Thank you for watching. I hope you can understand this topic. Thank you.